Hey guys, today we are going, actually there's a few things today. Basically we're going to build, prototype, we'll draw out the schematic, we'll prototype it on a breadboard, and then we'll solder it. We'll do it on a circuit board. We're going to do a 5-volt power regulator, DC to DC, so you can take almost any voltage. Actually, let me start opening my stuff here. Almost any voltage, like say 12, 7, 9, 6, and on one end, and have 5 volts come in out the other. We're doing this because we're doing a project, that sonic cane for the blind I'm building, and I need a nice clean 5 volts to power the Arduino Mini Pro and the sonic sensor. So, okay, let's take a look at our our 5-volt regulator first. So, go to sparkfun.com, and it is an LM7805. We'll type in 7805, and there it is, right here, voltage regulator. Okay, now it's very important to read the data sheets. This is the voltage regulator. You'll see this is the exact one I have. It says right on it L7805. But let's take a look at the data sheets. There should be a data sheet for this. Yep, right here. LM7805 5-volt power regulator. Now this is actually too big for my purposes. I won't say too big, but it's 1.5 amps max. We're probably going to be putting less than 200 milliamps through this. So what we're building is actually going to be good for a lot of your projects. And that's why I chose this. There's actually smaller 5-volt regulators. Let's see. Let's see if they have them here. Anyways, I'll show them to you in the video. They're exact same size as an NPN or a PNP. So let's go back to this guy. Oh, they actually have an unregulated power supply tutorial. I'll let you guys check that out on your own. Yeah. That's a pretty neat thing. It uses coils and everything else. So what we're doing is we're doing DC to DC. You need a bridge rectifier to go from AC to DC. So we're not actually going to be doing that. So this is going to be DC to DC. And this is the data sheet. Data sheets are very critical. If you buy a component, download the data sheet. It may be harder to get it later on if you want it. And when you do searches for data sheets, you'll find that there's the first things that pop up are all these companies that save all these data sheets and then want to charge you for them. So, but if you dig hard enough, usually you can find a data sheet for what you're looking for. Okay, so it has a couple of different packages. We're actually going to be using, this is the same package, it looks like, a KC and KCS. So the package, okay, these are a little longer here. I'm not sure which package we're dealing with. Let me see. KQ. Okay, not sure which package. It doesn't matter because for our purposes, whoops, sorry. Back to the data sheet. This is what it looks like. And by what it looks like is this piece is in the back. This is facing you. So when we're looking at this, these are the legs as they're showing it, looking at us, not the reverse angle. Do they have another side? Yeah, right here. This would be looking at it backwards, so the pins won't match up. So looking at our sheet, we have input, common, and output. And that's how it's going to look facing us. Like I said, it'll probably just ride a little higher on a circuit board. Other than Other than the length of these pins, I don't think there's a difference between these two packages. But feel free to read, maybe there is. So we have our input, our common, and then our output. This is critical, and it's great because this goes in the order that we're going to build our circuit. What else do we have down here? Ordering information, the different packages, the voltage. What I'm concerned with, this is I believe that's the internal schematic. Input voltage. It looks like we could do 40 volts. We've got our operating temperatures, which are important. If you're going to solder this thing, you don't want to blow it up. Storage temperature, minus 65 Celsius to 150 Celsius. None of us will see that in what we're using. Of course, unless you're trying to pump a whole lot of power to it, because it'll heat up. So we've got input voltage. It looks like we can do, let's call it 35 volts. We're going to actually be pumping 12 volts into it, maybe 18 volts, and having 5 volts come out the other side. What else do we have here? And you can get 3.3 volt ones as well if you're looking to have a nice clean 3.3 volts of power. Test conditions, parameters, output voltage, 5 milliamps to 1 amp. So basically this gives you all your information if you're wondering, what can I do with this? I know that this is I'm browsing it now, but I know that this particular one is well above what I need. Operational current up to 1.5 amps. I do not need that much for this project, but I'm going to put it in there. It's overkill. Better to be over than under. I'd be cutting it close with one of the smaller ones, because we're going to be powering two things. Actually, let's go back here and look at, and I know you guys want to get into it, and we'll get into it in a minute. But this stuff is important too, and you can always fast forward through it. Arduino, it's either Pro Mini or Mini Pro. Here, this guy right here. See, now these guys come in 5 volt and 3 volt flavors. Now, I told you to buy the Uno, and yes, you should be buying the Uno so you can buy shields for it. We're going to learn everything you can buy shields for. We're going to learn to build ourselves eventually. But if you want to get going with some of these projects, it's better to have that. I generally use these. I'll be using in my tutorials, I'll be using the Uno, or the equivalent to the Uno. In my projects, I actually use these. So this guy. So if we look at this guy, max 150 milliamp output. I don't know if I mentioned to you, but these pins, their output, you're going to actually use them to control larger voltages and larger current. Because these guys can only produce maybe 20 milliamps of current. So they're not very... we're not going to be controlling big things with the microcontroller. We're going to control things that control the bigger things. Like, you're going to learn how to control an air conditioner by this guy. One of our next projects, we're going to do some AC control, some other DC control, stuff like that. Okay, I guess I'm getting off schematic. The Mini Pro homepage. I want to see what he takes in for his Macs, because that's who we're going to be controlling. Now, we're only going to be controlling a couple of digital pins and an analog pin is all we're going to be controlling. So 3.3, 5 volts. Their input voltage, 5 to 12 volts. I believe that's on this guy here. We're actually going to be using this guy here. Neither of them is listed as raw. Raw is the unregulated voltage to the board. VCC is regulated 3.3 of 5 volts. So according to this should be regulated too, 5 volts here. I don't see a raw on here. There should be. Oh, there it is. There's the raw. So this guy actually has a built-in 5 volt regulator. So we could actually pump in raw voltage to him if we wanted to. But So, we have batteries that are probably going to be 6 volts, so we could pump it in here, no problem. But since we want to control him and we want to control the our sensor, our sonic sensor, we're still going to build the 5 volt regulator. So there's a lot of information. I strongly suggest you read it. I read it a while ago before I decided to do this project, and it met the specs of what I needed for the project. So there's our raw. So your raw, we can put in 5 to 12 volts. So that means 7 volts, 8 volts. Don't plug it into your car. If you put your multimeter on there, it's not a 12 volt regulated. You'll see like 18 volts. And I actually blew up Arduinos doing that. So I actually have a regulator that plugs into the car cigarette lighter, and then I can power my Arduino from that. And I'll show you guys that in a video. Okay, so back to our 5 volts. So that's one of the things I'm going to power for the project. The other item I'm going to power is a sonic sensor. And we're actually going to use this guy, the bad boy right here. We're going to do a wrist strap version of this, and we'll probably use this guy. I think I mentioned it to you before. The lower this number is, you can go into the spec sheets, you'll see all this. But the lower the number, the wider the beam. If we go into this guy here, and go into sensor selection, beam width explanation. You see these guys, they have the wider the beam, and it's detecting a certain, like a 1-inch diameter object over a certain thing. All of these will detect close to 25 feet. We'll do 25 feet detection, but it's different width or different diameter dowel, which is just, like think of it as like a pole, and how close and how far away you can detect those things. So we're actually going to be using this guy, and it's not today. I might edit out this video. I don't know. People seem to like it, so seem to like my rambling. So this is the guy we're going to use. And since we're building the regulator for this, that's why I'm going over this. Operates on 3 to 5.5 volts. We're going to have 5 volt regulated power coming out of this guy. And this 2.1 milliamp current. So actually this guy can be powered right from the Arduino, no problem. 2.1 milliamps. Or that's the low end. Let's see what the high end is. Let's go into the data sheet. Data sheets are good. This is how, see, this is my sensor range for this guy. I've got 20 feet. See this narrow beam? And A, B, and C is just those different dowels again. How thin an object can it detect at what distance. And these are feet. So 1 foot, 2 foot. See, this is 5 feet here, 10 feet. And see how narrow this beam is? And we're doing this for the blind, so we want it narrow. We don't want them walking down the street and having this sensor go off because there's a light pole here. We want as narrow a beam as possible. We still don't know this is going to work. We're prototyping this. Up here is, it's important to read all this stuff. We're going to start doing sensors with the Arduino. This is basically an electronics one, so I'm not going to get into these pins right now, other than to say we're going to use an analog. Here's our plus volts, here's our ground. And a lot of these guys, you have to read the data sheets, because to turn it off and on, you may have to bring one of these pins high, which means supply 5 volts of power to it. When we get into our wireless projects, a lot of the XPs, a lot of the more powerful XPs, require you to set a pin high to turn it on. I spent a half hour once trying to figure out why my wireless wasn't communicating. And when I read the data sheet, I had to set a pin high. So read the data sheets. And we looked in here because we wanted to see milliamps, what the draw on this is. This takes you through all those pins, and we'll go through that. And that's the end of the data sheet, huh? So where in here does it give my milliamps? Okay, let's do it the easy way. says it found it. Oh, okay. MA, max sensor. It's looking for anything where it finds MA. So there's a lot of words that contain MA in them. See, MA. It may be amps. It just could be a capital A and use point. There we go. Voltage. Here we go. Volt plus operates 3 to 5.5 volts. Current draw 3 volts and 5 volt operation is 2.1 milliamps. 50 milliamp peak. Okay, so we can't power it with the Arduino. I believe our digital pins and 3.4 milliamps, 100 milliamp peak respectively. So we are going to need this voltage regulator that we're creating to supply the extra added power that we need that we're not going to get from the board. It's during sonar pulse transmit. So yeah, so this goes up to 100. Now if we go back to our Arduino Pro Mini and the 5 volt version, and it doesn't matter because we're going to the Arduino Pro Mini page. DC current. See right here, DC current per I/O pin is 40 milliamps. So we cannot power that from a digital pin, because we're going to kick up to 100 milliamps. I think it said 35. So at 3.3 volts, we could probably do it, because it took less amperage. But we definitely, DC current per I/O pin is that. What's the milliamp rating actually? So we could probably power it off of this, though. Now that's the digital pins coming out. So the most we're going to get is 40 milliamps out of a digital pin, which is, you know, a couple of LEDs. So we need to power other things to power this. And I'm dying to do all these Arduino tutorials, but I know I've got to get some of these electronic ones done too. Input voltage. So we have 40 milliamps. So let's go LEDs. Let's do the search. I know it's going to come up with a lot of other stuff, but let's just highlight all of them. So there's 40 milliamps there. That's 40 milliamps again. So I'm trying to see what it will supply out of its maybe it's in amps. Like I said, sometimes you'll see milliamps, sometimes you'll see like 40 milliamps is 0.04 amps. 0.04 amps. 100 milliamps or 400 milliamps would be 0.4 milliamps. So sometimes in these data sheets you'll see things in milliamps, and sometimes you'll see them in amps using decimals. But anyways, we're going a certain direction, so we don't have to worry about this and finding out what this guy is capable of supplying. And it's probably based on what this guy is putting in. Actually, we can power this from this guy too. So we're actually going to put 5 volt regulated power in here as a volt in, positive volt in, and our ground. And our sensor is going to be in here too. When I tried to power it separately and just put in the analog pin for the sensor, it didn't work. And we'll actually go into that when we get into the Arduino sensors. We are just I am just going on and on and on. You guys need to let me know if you don't like all this extra stuff that I do. Let me know, and I'll make sure I can cut it out of the videos. But I think it's good for you guys. Oh, this is an excellent book right here, Making Things Talk. It has nothing to do with making things talk. It has to do with connecting your Arduino and connecting it to everything. Making things talk is making devices talk to each other. Think of it that way. Awesome book. I highly recommend this for your library. Okay, so we've got our 5-volt regulator. Let's go back to our 5-volt regulator. Let's go back to our data sheet. Now we're back on track. Okay, so we have our input, our common, and our output. That's going to be key in our design. Now these data sheets even give you a design, but we're not going to use theirs. Let's see. Whereas is going to be a little more complex, but I think it's going to be cleaner in the end. Output voltage. Input voltage regulation. Test conditions. Sometimes these data sheets can be hard to read. 10.5 volts to 25 volts. Output voltage regulation. 750 milliamps. 5 milliamps to 1.5 milliamps. So it looks like I'm not going to spend too much time on this. We're going to put anywhere from 6 to 12 volts in, and I actually tested it at lower voltages and lower than 10.5 volts, and it worked fine. Okay, electrical characteristics. Oh, positive voltage. Was that a negative voltage regulator up here? No, positive voltage. You can get negative voltage regulators too. We have them. Very easy to set up. Sorry, here's the point. Okay, application information. Now you want to take this positive voltage regulator and create regulated voltage. Okay, so on this side, this is their recommendation for a fixed output regulator, which is what we want. We don't want it varied. This is a positive regulator in a negative configuration. They give all these different scenarios that you can have. Adjustable output regulator, so you can use these. Current regulator, you can use these in all these different capacities. What we're concerned with for our application right here is the fixed output regulator. So according to these guys, you have your plus volts in. We're going to have 12 volts. You have a 0.33 UF. This is an electrolytic capacitor because this isn't flat. So this is the positive side of that capacitor. This is the negative, if you remember through our schematic drawings. And this is ground. So think of it. We'd have a positive. Let's say we had a 12-volt battery here. We'd plug 12-volt battery positive here, and the negative would be plugged here. This is where the negative is. So we have, and you'll see that when we do our schematic. This schematic, I try to build my schematics for understanding so people can understand it better. So you'll see on my schematic they'll have negative here. And this is the common pin. So this is with the guy facing us. So this is the input voltage. This is the common pin, and this is the volts out, VO, volts out. And I'll actually put DC because we're not doing AC coming in here and DC coming out. It's going to be DC to DC. And this is a 0.1 UF capacitor, and it's got electrolytic, but we're going to use an electrolytic, but we're going to use a 10 UF, and we're going to use a 0.1 ceramic capacitor here. And so this will be a positive out, and this will be your negative out. So your negative will go here. And we're going to draw that out right now. But this is theirs. Feel free to follow theirs to the T. It'll probably work just fine. We're not doing that. We're not testing it. You should have a whole sets of capacitors. You should buy tons of different capacitors for all the projects we're going to build. But we're not using this. We're going to use a 10 UF, and a 0.1 UF on this side, a 10 UF, and a 0.1 UF on this side. And let's get to drawing, I guess. And we're going to use a diode. They don't have a diode in here. Okay. We need this guy. Let's size it up a little. Okay. Let's draw our schematic for our 5-volt power regulator. Let's start here. Plus volt DC. We're using DC current here. So, we have plus volt DC, and we have minus. So, our ground. So we can take any power supply here. So, we go from here, and we have a diode. I saw the schematic on YouTube. He didn't really do a good job of putting it all together. I'll put a link down below just because I believe in giving credit where credit is due. So, okay, so our first is a electrolytic capacitor, which has polarity. And then he goes to the negative side. And next, now this is a 10 UF. (10 microfarad). That's what UF is. Farad is so huge, you're not using farads. So we have microfarads, and we're going to be using picofarads. So this, our next guy here, is a ceramic capacitor. This guy has polarity. This guy doesn't have polarity. It doesn't matter which way he goes in. That little dot is irritating me. Sorry, guys. Let's get rid of that. Whoosh. Okay. Then we go into, and we might as well just bring this line all the way across. This is our ground rail going all the way across. Now, when we breadboard this, it's going to be huge. But when we, because we're using the whole breadboard just to keep it open. But when we put it into our, actually, let me do this. Focus for a minute here. This is that the LM7805. It might have been an L7805. I believe it was LM7805. And then this is the common, and this guy goes to ground. And then this is the output. Now this is facing me. This plate is in the back. This black hump is up here, and the characters, whatever it is, L7805, blah 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 blah. The writing is facing us. On this. So this is the volt in that you saw, IN. This is the volt out. You'll see it as VO. We'll actually do out, VO. And this is the common here. Which goes to ground. Now we go volt out. And we have the electrolytic capacitor again. And I'm going to explain in a minute, what are these capacitors for? Why are we putting them in here? We know, so far, in our lessons that we use them to store electricity. And that's all we use them for. But, more commonly, actually, I don't know necessarily more commonly, but they're also used. Now, this is the 0.1 UF, or 100 nanofarad. This would also be 100 nanofarad. And there's two common capacitors we're going to use in a lot of our tutorials, ceramic capacitors. They're 0.1 UF and 0.01 UF. or you also see them as nanofarad, NF. But for nanofarad, it would be 100 nanofarad and 10 nanofarad, respectively. So this guy is this here, and this guy is this here. So, so these are two common ones. And what you're going to see, there's numbers on these guys. And this guy is going to read 104. You'll see a number on him, 104. And this guy, you're going to see a number on him, 103. So to find these capacitors in your parts bin, look for a ceramic capacitor with 104, a ceramic capacitor with 103. For this guy, it's going to be 104. So this guy is 104. And so is this guy. He's a 0.1 UF or 100 nanofarad. And his package will say 104 on it. You'll see that. And this again is a 10 UF. And it'll say 10 UF on it. It'll also give a voltage rating. Our max here that I'm going to use here would be 12 volts. So, and I believe this capacitor has a 50 voltage rating. You'll see volt. It'll say on the side of the capacitor, on the electrolytic capacitor, it'll say 50 V 10 UF, which means the most I could use for voltage for this is 50 volts. And on this side we'll have 12 volts, and on this side, and once again this is the positive side because these guys have polarity, and on this side it'll be 5 volts. So it's well within tolerances for these capacitors here. Okay, so here is our schematic, and this is it. So we may want to hook this up to, we're actually going to hook it up to an Arduino, but in the link for the video, he actually hooked it up to a resistor, and then he hooked it up to an LED, and then back to ground. And because this is 5 volts, we'll just call this, you can use a 470. I think he used a 1K resistor, which is a little high. But you can use a 220 or a 470. We'll call it 470. 1K would work too. It'd just be a little dimmer. It would last a little longer. 470 ohms resistor and LED, of course. We know that from the schematic diagram. So we would have, let's call it 12 volt. We could put 7. We're actually going to test this when we build it, when we breadboard it. We'll put 12 volts here, 12 volt plus, and these are all DC volts that we're dealing with. And that's it. That's our schematic. Plus VDC, actually, so plus 5 volt DC on this end here. So we connect anywhere here. And this is, of course, our ground. The ground. The negative. The cathode. Oh, when I did that, I got to add that to the video, by the way. There's one I left out. I did positive, negative, anode, and cathode. Sometimes when you buy LEDs, color-changing LEDs, they'll have one pin longer than the other. You can get these in common anode or common cathode. So common anode, what happens is you put the plus volts here, and then you pull these low to light up the red, green, blue. So you pull it low to light up the red, green, blue. I prefer the common cathode, where this guy is negative, and then you add plus volts to each of these, and you can use pulse width modulation to control the amount of color, and you'll have red, green, blue. I don't know what the leads are, which one's red, green, blue. But then you'll hook it up to, say, your Arduino, and you could power each one of these having red, green, and blue, and you can make the different colors. Actually, you could do an LED, giant Vegas LED TV set doing these with enough control. Of course, you'd use shift registers and stuff. You wouldn't use an Arduino Mega can only power only has 54 pins, so you're talking about 1, 2, 3 being taken up per LED. But another project. We'll get into that. But I just wanted to mention anode and cathode, because I left that out of the positive negative. Remember I said VCC, VS on an earlier tutorial. Okay. Sorry guys, I left out one critical thing. What are these capacitors doing? I forgot to tell you that. They're removing low and high frequency power fluctuations. That's all they're doing. They're removing low and high power frequency fluctuations. So do we really need it like this? No. This is extra added bonus protection. So it helps smooth out power. That's the other thing that the other things capacitors do. And actually, I'm going to insert it before I started talking about this. I can't believe I forgot that. So here's our diode. So we have directional power in. We have our capacitors that smooth out our power. We have our regulator that regulates 5 volts out. We have our capacitors that smooth out our power again. And when we get it to the oscilloscope, I can show you what I mean by that. And then we have our 5 volt conditioned power going out and then coming back to ground. I can't believe I almost forgot that. Okay guys, we're in the robotics club right now. That is an old radio that we took apart for parts. Plenty of good parts in there. That is voice over laser pointer using pulse width modulation. That's a robot being built. And this is our project for a sonic walking stick for the blind. And I managed to get it working yesterday. The thing is I'm using the Arduino Pro Mini, this guy right here, and he, once he's programmed and ready to go, which he is, he's going to need 5 volt power. And so is this guy's going to need 5 volt power too. This is the sonic part. And we'll go over these pins in a minute. But actually after we do the 5 volt regulator. So anyways, we're going to need a 5 volt regulator for this walking stick. So we may put a 9 volt battery in there. We may put 2 3 volt batteries, or whatever we put in, we're going to need 5 volts. There is no 5 volt battery. I guess you could put in 6 volts worth of batteries and put a couple of diodes in there, or resistor or something like that. But I thought this would be a good time to build our own DC to DC 5 volt power regulator, and this is what we're using. This is the main portion of the circuit, as you know from the lecture portion of this. And it is a LM7805 5 volt regulator. So we'll I guess we'll build it. Let's build it. Let's put it together. Okay, so let's give ourselves a bit of a schematic. Just to go by, it makes it easier. You should write it down from the lecture, but anyways, I'm going to draw it out again. We have plus volts over here. We have a diode. And then we have, I believe it is the electrolytic capacitor. Of course, this is the positive side. And then we have a ceramic capacitor. Now this one here is 10 UF, and this one there's no polarity, and this is 0.1 UF, and you'll see on the capacitor itself, I don't know if you're going to be able to see it on here, it actually says 104. then we have our when you're looking at it, you look at it this way. This is face on. So this is the input pin. This second one is the common, and then the third is the output pin when it's facing you. Like I said, we're up at the Robotics Club, so we've got music in the background. And let's just breadboard this. And I guess I didn't leave myself enough room. Actually, let's redraw it. Let me get a bigger piece of paper. Okay, we've got a bigger piece of paper now. And we've got plus volts. We've got our diode. I believe this is a 1N4007. And of course down here is ground. And here we have electrolytic capacitor, 10 UF, ceramic capacitor, which is 0.1 UF. You'll also see on the capacitor itself it says 104. Let's see if we can look at that now. So this is our, actually we'll go over the parts after we draw it out. And this is all connected on the ground. We then have our LM7805. So this is LM7805. It is also known as just a 7805. And we have our input pin. We have our ground pin, which is in the center. And then we have our output pin. So we come over here with the ground, and then we have our output. And then we, once again, we have another electrolytic capacitor. And this is the positive side. Positive side. Same thing, 10 UF. And we have a ceramic capacitor. Same thing, it's a 0.1 UF, and you'll see 104 on it. Now this is blue, usually these are like orange. This is the 104. I don't know if you could see the 104 on here, or even which way it's on here. And I needed a magnifying glass to see it, but, oh, okay, you can see that in the camera, 104. Usually they're orange, this just happens to be blue. And this is, so this is in, volt in. This is out, which is 5 volt plus out in our common ground. So what we would do is we'd attach something, the positive side here and the negative side here. And this we could put 12 volts, 6 volts, 7 volts, and this will regulate our power. Like I showed you in the lecture portion, this isn't exactly how they set it up. And I think I mentioned the reason why I set it up this way. The electrolytic capacitor and the ceramic capacitor take out low and high frequency distortions in the power. So it smooths out the current before and after the, so that's basically what it does. It smooths out our current before and after the 5-volt regulator. So no matter what we put for voltage here, as long as it meets the specs of the 7805, and we can get a 3.3 volt regulator too. So whatever we put in, coming in on this side, we're going to get a nice clean 5 volts out on the other side. Okay, so we have our schematic. Now let's build it. It's actually quite a few, we have quite a few cables to build this. Even though it looks simple, I mean, these are all connected to ground. They're all connected to the same ground. And let me put ground on this side. They're all connected to the same ground, and then these are all on the positive to the input pin. Once again, input pin, common, which is the ground, output pin. And we already went through the, and you see 7805 on there, and we already went through the data sheet for this guy. Oh, we took a quick look at it anyway. Okay, so let's build this. Let's build this guy. Okay, now facing us, this is going to go into row A. We're going to put it into 17, 15, 16, and 17. Actually, you know what? That's kind of upside down. Let's do it this way. So it's going to be in row J, and it's going to be 14, 15, and 16. From left to right. So 14, 15, 16 in row J. I don't know if I can do a close-up of that because I zoomed in, but, and I want you to see the direction of that. See what's facing me? Remember when we went through the schematic, I showed you the line, and that meant it wasn't facing this way, that it was facing this way. Okay, so the first thing we want to do is we want to put we want to have our diode, so which makes sure that the electricity only flows in one direction. And remember, this side is positive, and the side with the silver ring goes towards negative. So whatever we use for power, we're going to put, let's do it this way. We're going to put it in we're going to put it in F1 is what we're going to do. So we're going to put our diode, in J1 and J3. J1, come on. J1 and J3. There we go. J1 and J3. Where did my electrolytic capacitors go? I think they disappeared. There's one. Where the other? Oh, there it is. Here's our 2 electrolytic capacitors and our 2 ceramic capacitors. So let's take the electrolytic first, and you'll see the long end is the positive end, the short end is the negative end, and you'll see the negative symbols on there. And you should be able to read that this is 10 UF up to 50 volts. is what that says. Exactly what it says is 10 UF space 50 V. And that's just above the negative line. So this is a 10 UF. And remember, we want the long end in the positive. And what we can do is I can go right here and put it into F3 and F3 and E3. Another new breadboard. Okay. So I had to put it in D3 because E3 just wasn't working out. And if you notice, it's bent towards me. That's because one leg is shorter than the other. And if I lifted it straight up, I probably wouldn't make contact with the other end. Okay, so now we have this guy in. And the next thing we should do is put our ceramic capacitor in. And this guy I'm going to put in F6 and D6. F6 and D6. So we haven't connected these guys yet, but we've put them in here. So our diode is connected to the positive side of this capacitor, but then this is not connected to that one. So let's take, we'll use green for positive. And we'll take and connect. I'm putting this into H3, which connects both the negative side of the diode and the positive side of the electrolytic capacitor. And then I put that into H6. So H3 to H6. And that actually connects there is no positive side for the ceramic capacitor, but we'll just call it our positive side of our ceramic capacitor. So that's fine. Now we need to go from this positive side of the ceramic capacitor. So I'm going to put this in J6 over to I14, which is the input pin on the 7805. So we're over to the input pin on the 7805. And I'll do a close-up of this when we're done, and from many angles. Okay, now one of the things I could do is I could use a lot of wires for negative, but I think what I'm going to do is I'm actually going to change the way I did this. And what I'm going to do is I'm going to take the negative side of that ceramic capacitor and I'm going to put it in B3. So now it's in the same row as the negative side. Just make sure that this negative side of this capacitor doesn't touch the positive side of that capacitor. The two negative ends can touch each other. That's no problem. They go into the same rail anyway. But make sure it doesn't. That way we get one. We have to use one less of these wires to connect them on that end, because it doesn't need to be connected like that. Okay. Okay, so we've got that in there. We've got that in B3. Okay, so if we look at our schematic, what we have is we have this diode connected here, and then connected here. And these two are in the same row, so those are connected, but they're not connected to ground yet. So what we're going to do is we're going to take a black cable, and this black cable we're going to put into C3. Now I want to leave one more open there because we've got to either we go off of the ground rail. Actually, I guess we don't. We'll just go off the ground rail. So I'm going to put it in A3, and then to the ground rail. So we have A3 to the ground rail, and that takes these two guys here and puts them in the ground rail. So now we need another for our common on the 7805, or our ground on the 7805. I'm going to plug this into F. What number is that? F15, which is the center pin on the 7805, and bring that over to ground. So that's come over to ground now too. Oh, sorry, off camera. So I plugged that into the center of the 7805 and then into the ground rail. So now if we look at our schematic, we've got this half of our circuit built. Actually, a little more than half of our circuit built. Okay, now we need to go from the output, which is in row 16. So we're going to go from H16. We're going to go from H16 to J22. So we went from H16 to J22. Actually, I think I'm going to make that a little closer. Let's save some space here. We're going to put it in J20. So we went from H16 to J20, which is right here. Okay, now we need our other 10 UF capacitor. Once again, long end positive, short end negative. Long end is going into F20, and then the short end is going to go into D20. There we go. So you'll see the long end and then the short end. And now I'm going to do the same thing with this 104 or 0.1 UF or 100 nanofarad ceramic capacitor. And I'm going to put it in F24 and F24 to C20. So the positive side is in F24, and the negative side is in the same row as the negative side of the electrolytic capacitor. So once again, we're saving ourselves another wire. And then both of these are going to go to ground. So what I'm going to do is I'm going to put a ground wire in A20 and then into the ground rail. So there we go. We have, so both of these are grounded, which is this portion of our circuit here. So what happened was this guy and this guy went into the same rail, and then I took a wire and I plugged them into the ground rail, or the ground plane. By the way, guys, I thought I'd mention this. I'm editing the video, and you know how I put both of these into the same rail and these ones too? You can do the same thing for the positive. If I did that, though, there was a chance that this negative wire could touch that positive wire. So that's the only reason I didn't do that. I don't want you guys to think you have to keep the positive separated and then connect by a wire. It's the same thing whether they're connected by a wire or they're connected in the same rail. Anyways, just wanted you to know that, if you prefer it that way. Okay, so now I need another green wire to go from the positive side of the electrolytic capacitor, and I'm putting that in I20 over to I24, which is the positive side of the electrolytic capacitor. Remember, polarity doesn't matter with these guys, but we still have a positive and a negative side on them that we're using right now. And then what we're going to do is we're going to go and we're going to use a red wire for this. because this is going to our power. So this is going to be our output power. If you notice on here, we go from this guy to our 5-volt out. So I'm going to use a red wire and I'm going to put it in J24. And that's going to be our 5-volt positive out. J24, 5-volt positive out. And then I'll take, do I have another black wire? Yes, I do. Then I'm going to take a black wire and I'm going to put it in the ground rail. I put it in the ground rail, and that is our negative out, our negative 5-volt out. So that's the negative side of our 5-volt regulator. And that's it, our circuit's done. So I think now we need to test it. Okay. Let's zoom out here. Or actually, yeah, let's zoom out. Let's take a good look at this first. Now, actually, let's put our volt in, I think. Because we need a ground volt in here and another one in this. So, what I'm going to use is this power supply right here, which, this is a variable power supply. We'll kick it right up to 12. We're going to put 12 volts when we plug this in. So we're going to have 12 volts going in here. And of course, this is regulated power too. So on this particular power supply, the white-black is negative and the black is positive. So of course it's stranded wire in here, so it's going to be hard to get into our breadboard. But I will do my best. So the white and black, which is the ground, I tested it prior, is going to go into the negative. And I'm using a pin to help me push it in there. Okay, that's in there good enough. And the positive end is going to go into F1. Okay, and that's in there good as well. Okay, so now let's take a look at this. Let's take a nice close look. You know, see there's the ground into the ground rail, and the positive into this first row, or column, depending on how you're looking at it. Here, and then through our diode, it goes to the positive side of this electrolytic capacitor, then to the positive side of the ceramic capacitor, and then from the positive side of this ceramic capacitor over to the input pin on the 7805, and then on this side we have both of these are in the same rail, and then they go into ground. And then we have the common, or the center pin, on the 7805. That actually goes to ground as well. Then we have the output, which is the right side pin, that goes from H16, which is on the right side of the 7805, over to the positive side of the electrolytic capacitor again, then from the positive side of the electrolytic capacitor over to the positive side of the ceramic capacitor, and then from the positive side of the ceramic capacitor over to our positive 5-volt lead. And on the negative side, we have both of these guys going in the same rail, and then coming over another wire connecting them to the ground rail, and this will be our negative for our 5 volts. And that's our completed circuit. Let's look at it from a couple of different angles. So you guys see, this is what I was talking about. We don't want this leg to connect to that positive leg, which it's not. If it touches the negative leg over here, that's fine. But we don't want it to hit that positive leg. So, like I said, they're both going into the same rail. Same thing over here. They're going into the same rail, so it doesn't matter if that negative touches that negative. It's the same thing as going into the same rail. So there it is again. Let's take a look at it from this angle. It's something right. Okay. And then from this angle. You guys can hit pause if you need to. And there it is. That's we built it on a breadboard, and I'm going to solder this in because I need to use it. And when I solder it, it's going to be a lot smaller than this. I believe, I haven't done the math yet, but I believe I'm going to use one of these guys again, and I think I could split him in half. You know, just have one of these leads as a ground that everything goes to, but we'll see. Anyways, let's test this circuit first. So right now I'm going to plug this guy in. He's at 12 volts, so I'm going to go plug this in. Okay, so he's plugged in. Let's get our voltmeter up and running. Now, I know it's 12 volts, so I'm just going to put it at 20. I don't need to put it higher than that. Once again, this is DC. The wavy line is AC. And we're at 20. And you can see what he is. And we will touch the positive side and the negative side. And if you notice, it's reading 13.63 volts. It's 12 volts, it's not under load. But now let's look at, so that's what we have going in. Let's look at what's coming out. So we have this guy here, and this guy here, and look at that. We have a positive 5.06 volts. So we've taken our 12 volt source and we've made 5.6 volts. Okay, now let's kick this down to 9 volts. Actually, let's skip 9 volts. Let's go to 7.5 volts. And we'll look positive here, negative here. And it's reading 8.76 volts. If I kicked it up to 9, it would be well over 9. Even a 9 volt fresh 9 volt battery is well over 9 volts. That's 10.2 volts. Let's go. Let's actually bring it down to 6 volts. And we measure that, and it's 7.56 volts there. And now on this side, we have 5.5 volts. Now, the more amps we pump through this, the more current we pump through it, and the more volts we put on the other end, we'll actually be using this heat sink. That's what this is here, is a heat sink. Now we can actually screw that down to a piece of metal, and it would really disperse the heat much better. But this should, and that's what that little hole for is, for a screw. But this should be good enough for our purposes. We have less than 200 milliamps going through this. Going to be going through this, so it's not actually going to heat up at all. Okay, so we definitely have 5 volts. And that's how you create a regulated 5-volt power supply. Now, if we took that diode, we could actually get it lower than 5 volts. If we put another diode in there, it would take off let's say you were using a 4.5 volt laser pen. Most laser pens are, laser pointers are 4.5 volts. Most lasers you buy are 3 and 6 volts is what I use for them. But those cheapo little laser pens are usually 4.5 volts. by cheap I meant like this one here. This is actually 4.5 volts, and the way it gets the 4.5 volts is it actually has to pass through. It's 5 volt. There's a 5 volt regulator on this, but it actually has to pass through a diode, which takes off that half a volt, or it gets it within specs for the guy, anyways. Okay, for the laser diode. Once again, that's a look at our quick and dirty schematic, and that's a look at the circuit. And I also talked to you earlier, I gave credit for the guy on YouTube who put this together. I've seen it's a pretty common circuit, but I saw him put it together. I thought it was nice that he did that. So this is how we built our 5 volt power regulator. And the next one, I might put a little bonus footage of me soldering this, but the next video that we're going to do is we're going to do some more sensors on the Arduino. And we'll use the bigger Arduino board, not this one. Although I will teach you guys, this is a FIDI adapter, not a cable. It's a FIDI, so it goes micro USB to FIDI, and that actually plugs into here. I don't think I showed you that. I actually soldered these pins on here, and then that fits in right there, and it says black on one side of that, green on the other. And if you look here, you've got a black and a green, and then you plug it in regular USB, and once you install that FIDI driver that I showed you, you can use these cables and you're all set. Okay guys, we're going to solder our 5 volt now. What I did was I took a breadboard and I looked at what we need. Notice how small, proto board. Notice how much smaller it is on the proto board. Look at that. We did it large on the breadboard because, just so we could space everything out and see how it looked. But this is basically how it's going to look on when we solder it. This is our, of course, I've been talking about many things this video, but this is our 5 volt regulator. So let me take these things out and we'll start to solder them. And I have to do some connections. I think I might run out of ground connections down here. But we'll see. Let's start soldering. Kind of like some bonus footage, I guess. I'm sure by now you guys can solder your own stuff and figure out how to fit it on the proto board and know what's connected to what. But I will start with removing these. And I guess I'll show a close-up of each part as I do it. Okay, the first part we want to solder is the diode, and of course I have this backwards because we're soldering this way. I like looking at the copper when I was putting everything in. There are white highlights here that I could have used as well, but I know now that I'm building it to do it on this side. So our first component is our diode. And hopefully the soldering iron is heated up. Tip tinner. Of course, I got my iron cleaner, my tip tinner, and my lead-free solder, which is harder to work with. The fumes are just as bad for you. I don't have my fan with me, so you'll notice me blow every once in a while. But you're not contributing a lot of lead to the environment, so you choose what you're going to use. And of course I have my big light and my big mirror, my big magnifying glass. Okay, this helps me solder a lot better. I remember originally doing the soldering tutorial. No, I don't think it's hot enough yet. It's getting there, almost. And it's almost time for a new tip as well. Okay, let's see what this does now. Yeah, it's not holding a tin, so put a little on the soldering iron to connect the solder. Come on. It might already be time for a new tip. Yeah, that didn't take well. Maybe it's these proto boards after all. Let's see how this one does. It's also a big component. Takes a lot to heat up that component. The wires on the diode are pretty thick. So it takes a lot to heat them up, and I usually like them, and that's usually why I use them to jumper. Like, we're going to be doing some jumpering on this breadboard to connect all the ground components together. Let's see, is that out of camera? Oh, I think I just kicked the camera. Sorry. So, was that? Yeah, that was almost out of camera. Let me see if I can fix this a little. Whoa. That should do it. Okay, so we have the first component on here, and I can't do too close up because it won't focus. So there's our diode, and of course we have 4 capacitors, and the next one we want is our electrolytic. And what I'm going to do here is I'm going to start using this as a ground. So the positive on this guy, the positive on this electrolytic, could go to the negative side of the diode we just put in there. Now remember, when I connect the power, I need to connect it to the same rail that the positive side of the diode is on. So we're actually going to put a wire or something in like that. And actually, before I do this, I should have broken this board, because I planned on breaking it for the and did I get enough of it? Yep, I believe I got enough of the board. Now, I also need to chip some of this off, because that's going to be too much, but let's see. Let's see what happens here. We've got this guy. Needs to go here. And then off of him to ground. Then he jumps over there to this guy, and this guy goes to ground as well. So we want to break it right around here. Let's see if we can do that. Perfect. That's exactly what we need. So you can see what I've broken off of here. Nice and thin. And that should actually fit into the tube we need it to fit into as well. I might have to get rid of this down here. Actually, let me do that now. There. What I did was I cut that one right along the holes. That should be perfect. Okay, so our diode's in there, and I'm not going to put this guy in yet. This guy can ride a little high. He's got those pins in there. But I'm going to need space underneath that brick part of him that sticks out. So we chipped away, as you can see, and this is all I'm going to need. No, I don't need much more than that. And you see the 3 holes connected together. I'm going to have to patch some of these 3 holes together so we have this big common ground, which I'm going to do as we go along. So I'm not putting this guy in yet, because where I'm connecting some of these holes, and actually maybe I'll do that first right now. Take one of these, and I want to connect this positive I should probably go one more over. And then he's going to connect in here to ground. This one's going to connect in here to ground. Going to connect in there to ground. That one's going to connect in there to ground, and then the positive comes off of that. Yeah, that works. And this guy is over here to ground. And then this one is over here to ground. Actually, I can move that over one more, no problem. So I actually have some extra. And this guy goes here. And that gets connected. Okay. I don't know if you see that, but you get to hear my babble too. So hopefully you guys see what I'm doing, and if you don't, even when I hold it up at the end, I'm sure you guys can figure out how to put it on a breadboard to minimize the space you take up. There's another positive to positive. And ply is a great thing to have. Goes right down to there like that. See that guy? He connects my positive side together. Positive to positive, and I'm just using the pieces of the other devices. Actually, I should probably use some helping hands for this. At this point, use some helping hands just to hold this. Let me face it this way so maybe you guys can see it better. Here. Yeah. Once again, this is these big thick wires from the diode. I'm really starting to think I need to replace this head. Yeah. That's good enough for that side. That's good enough for that side. Good. Not too shabby. Okay. So we've got that positive. Now we want to take our we're going to take our electrolytic capacitor and we're going to put it here and here. I don't know if you can see that. This is going to be the negative, and eventually this negative is going to come down here too, because we're going to need more negative space. But I might mount him a little high, or mount him at the same time. Make sure I get him underneath there. This guy's going to go here. Or, you know what? Let's mount this guy first. Come out from here. Okay, she's not the prettiest, and I had an issue. I put a capacitor, electrolytic capacitor in backwards, then I had to remove it and put it in right, and then I removed the wrong one. These are the things that can go wrong, and I was trying to talk while I was doing this, and I should have just kept quiet. Now I still need to add power and ground to either end of this circuit, but it's pretty much done. It's about as small as I could make it, so